This is section 6.3. This is special factoring. What we're going to do now is we're going to be talking about some of our special cases. If you look at your factoring guide, the first thing we still do is we factor out a GCF. That does not change. What we're going to be dealing with now is whether or not we have two terms. We'll be talking about these possibilities. We're going to be talking about this possibility where you have a perfect square trinomial as well. After this section, you should have everything you need to be able to follow this chart completely. All right, so our special formulas. We have a difference of squares. We saw this back in chapter 5. We dealt with it in the opposite direction though. If you were multiplying two things with the same two terms and one was positive, one was negative, you got to just square each piece with a minus in the middle. Now we're going to be starting off here and we're going to go this direction. The same thing with the perfect square trinomials. In chapter 5, we started off with this side and we went to here. And now we're going to be going from here to here. Okay? Now, these can all be worked using what we learned in section 6.2. You really don't want to do that though. Because it's really much easier if you can learn to recognize these. And we're going to be talking through this process, okay? If you took Math 320, you saw these before. If you took Math 320, you did not see these two. These are new to this course. We also did not cover these in chapter 5. We did do a problem involving these. If you go back and look at dividing polynomials at the end of chapter 5, you'll see these things popping up, okay? But that's not that critical. If you have a difference of cubes, okay, you need to have a perfect cube here and a perfect cube here. Sum of cubes is perfect cube, plus sign, minus sign, okay? If you look at these, our letters, our terms are exactly the same all the way through. The only difference are our signs. This first sign matches the sign that we have. So a plus here, minus here, minus here. These last two are always plus, that doesn't matter. This sign is the opposite of this sign. So this one matches, this one's different. This one matches, this one's different. Okay? One other thing I want to point out is how similar these are. Up here we have a 2 on that middle term. Here we don't. And that makes a huge difference. Something in this pattern is factorable. Something in this pattern is not. Okay? What we're going to be doing is we're going to be coming back to all these. We're going to work a lot of examples of them. One thing I do want to show you are some perfect square numbers. You would want to be able to recognize these fairly quickly. 1 is a perfect cube because it's 1 cubed. 8 is 2 cubed. 27 is 3 cubed. 64 is 4 cubed. 125 is 5 cubed. Okay, I gave you 6, 7, 8, and 9 cubed, but we don't see these that often in the homework. You also see 10 cubed, which is 1,000. The ones with the little red dots are the ones that we see most often in the homework, okay? If you are ever unsure as to whether or not something is a perfect cube, what you want to do is if you look on this calculator, look right up here, you'll see a box and then a square root. What you want to do is you want to test to see if something is a cube root. So you'll hit 3. And then since it's above that, you're going to hit second and then that, and you can see that that 3 pops up there on our radical sign. And say I want to check to see if 125 is a perfect cube, I would enter 125 and I get 5, so it works. But if I wanted to check the cube root of 126, that's not a perfect cube. You're going to get some ugly decimal. Okay, if you get an ugly decimal, not perfect cube, get a nice number, it is. Okay. So let's talk our way through these problems. The first thing we want to try to factor is k squared minus 9. Okay, if we factor, following our factoring guide, factor out a GCF if we have one. There's nothing that these two have in common, so we do not have a GCF. Okay. We do not have 4 terms. We do have 2 terms. Is there a plus sign in the middle? No. Are the 2 terms perfect cubes? Well, that's a perfect square. That's a perfect square. These are not perfect cubes, so no. So now we're going to try difference of squares. Okay, so difference of squares, I've rewritten everything on this note card so we can easily refer to it. We need to have a perfect square minus a perfect square. And right here, what we need to figure out is what this is without the square. So basically, we're asking what's the square root of these things. The square root of k squared is going to be k. The square root of 9 is a 3. So what this is going to be in our pattern, this is going to be our A, and this is going to be our B. So the pattern is A plus B times A minus B. So this factors as k plus 3, k minus 3. It's my own personal habit to write the plus first, but you could do k minus 3 times k plus 3, and it's the same thing. Okay, so let's try 81x squared minus 36. Our first step is to factor out a GCF. Now you might notice here that we have 2 terms with a minus sign, and these are both perfect square numbers. You could do difference of squares first, but then you're going to have to factor out numbers at the end. It's really much easier if you factor out the GCF first. If you look at 81 and 36, both of these numbers are divisible by a 9. So let's factor out that 9. That will give me 9x squared minus 4. If you had perfect squares here and you have a GCF, you're going to have perfect squares in here as well. Okay, so let's talk about what our square roots are. The square root of 9x squared, you take the square root of each piece. This is going to be a 3 and an x, and this is going to be a 2. Okay, so this is my A, this is my B. The 9, as a traveler, we cannot lose it. So it's 9 times 3x plus 2 times 3x minus 2. Your answers are always to factor completely, so you want to make sure nothing else doesn't break down any further, and it does not. Okay, so just as an aside, what happens if you did not recognize this as that you could factor out a 9? So let's say I started off like this, and I noticed that this was a perfect square, and its square root is 9x, and the square root here is a 6. Well, if I use difference of squares here, I would have 9x plus 6 times 9x minus 6. You always need to ask yourself if you factored completely, and if you look at these two, you should see that you could factor out a 3 to get 3x plus 2, and then here you could also factor out a 3 to get the 3x minus 2, and then you'd multiply the 3 times the 3 to get the 9. So you can see it is workable if you don't factor out the GCF first, but I think you can also see that it is much easier if you do factor it out. Okay, so let's try 243x to the 4th times 3t to the 4th. Okay, first step, factor out a GCF. And I'm kind of looking ahead, and I see that I have 2 terms, so I'm hoping it is a perfect squares on the ends or perfect cubes. Okay, but I know 3 is prime. It is not a perfect square. It is not a perfect cube. So what I hope is that I can factor a 3 out of this. Is 243 divisible by 3? Yes, I get 81. Okay, so what I'm going to do first is I'm going to factor out that 3. And that gives me 81x to the 4th minus t to the 4th. Now, one thing I want to point out is I was able to factor out a GCF. That means this thing is not going to be prime. Even if this doesn't factor any further, because I was able to factor out a 3, my answer is not prime. I will have an answer. Okay. Now, let's look at what we have here. I have fourth powers here. I don't have squares. I don't have cubes. What we need to remember is from section 5.1, we had this property right here. A power raised to a power, you can multiply those together. What this means for us is anytime you have an even power, it is a perfect square. I can rewrite x to the fourth as x squared squared. Because a power raised to a power, I would multiply those together to get a 4. Now also, I said any even power, if I did x to the sixth, I could write this as x cubed squared. Multiply those together and you get back to 6. Any even power is a perfect square. Okay? So keeping that in mind, the square root of 81 and x to the fourth would be 9x squared. The square root of t to the fourth would be t squared. I have two terms with a minus sign in the middle, and they are perfect squares, so I have a difference of squares. We cannot lose that 3. Make sure it follows you down. And then you get 9x squared plus t squared times 9x squared minus t squared. Okay, our directions are always to factor completely. We factored out a 3, and now we need to check to see if these factor any further. I do not have a GCF in either one, which is good. But I still have powers in here, which means I really need to check to see if it factors further. It might not. Okay? Well, look right here. I have two terms. Okay? So I have two terms. Do I have a plus sign in the middle? Yes. Do I have a sum of cubes? Well, 9 is not a perfect cube. X squared is not a perfect cube, nor is t squared. So this is not a sum of cubes. It's not a difference of squares. There's nothing I can do with this one. But right here, I have a minus sign in the middle, and I have perfect squares. So this one is another difference of squares. The square root of 9x squared is going to be a 3x. The square root of t squared is t. So overall, this factors as 3 times 9x squared plus t squared. These travel down from here. So this was a traveler here, and now both of these are travelers. And now we use these two to rewrite this. So this will be 3x plus t times 3x minus t. This happens a whole lot when you have exponents that are to the fourth power exponents. It's often, and this is just the way the problems are written in this particular course. This is not true for all time. In this course, when you have an x to the fourth, it's often going to be a difference of squares that you have to factor twice.